welcome everybody. So I'm really looking forward, I've been looking forward the last weeks to this event, and I'm really happy to see you here, all in Tokyo. So I have the honor to talk today about how we as AUTOSAR organization embrace the software-defined vehicle in the future. So let's have a look on the first page. If the clicker is working, so Ray, you may jump in. Okay, now it's working, thank you. So we had in the last year, as Günther has been mentioning, we had the 20th anniversary of AUTOSAR. Before we go there, let's have a look what we will cover here. So I will take over a general introduction, what has happened in AUTOSAR over the last period of time, what AUTOSAR is, where do we stand from a development and ecosystem perspective. Then a colleague of mine will give you an idea of what the SDV understanding of AUTOSAR is, before we then talk about how the AUTOSAR adaptive platform is going to serve the purpose of the software-defined vehicle. And then we will do the same with the classic platform, and then we will give you some ideas what's coming in the future for the AUTOSAR organization. So please go ahead. Here you can see, as Günther has already mentioned, we had last year our 20th anniversary. So looking at the overall age of the software ecosystem, which has been shown by Geoffroy very well, we are already had a big portion of that history. So, and we're also looking, of course, towards software engineering and going more into the software engineering. So, having said that, what is the mission of the AUTOSAR? Okay. So, Ray, where do we are? Okay. So the mission of AUTOSAR is basically to have a standardized ecosystem for EE architectures, and have this in the context of the. I'm fighting similar software challenges as my predecessor. Okay, I will let you know. So let's go with the mission again. So for us it is very important that we have a standard that serves an open EE architecture, and a standard that serves the future of intelligent mobility. And as this, we are working not only in the field of software, but also in the field of systems. And this is why AUTOSAR is called Automotive Open System Architecture. It's often misinterpreted as only software architecture. So let's come then basically to the next slide. From a mission perspective, we are a global established standard. So we will see our global distribution also later in the slide set. And we have basically software, we have methodology, and as mentioned, system aspects. Looking at our next slide, we will see that out of the top selling 20 OEMs, most of them base the system on AUTOSAR. So from a market perspective, over the last 20 years, AUTOSAR has reached a major penetration among OEMs, Tier 1, and other players in the mobility ecosystem. Then, looking at the next slide, you see our distribution of partners. As you can see, AUTOSAR started to be very Europe-centric, but in the meantime, that's why I'm happy why I'm here in Asia. Asia has the biggest amount of AUTOSAR partners, so 166 coming from that region. And this is basically emphasizing we want to serve globally, not just for a local area, and we will also see more details on our global share of our regions later on in the afternoon. So next slide, please. So the base principle for AUTOSAR is the same since 20 years. So when you talk about AUTOSAR, the original intention was to decouple software from hardware, to be able to move applications from one ECU to another ECU, to be able to reuse your basic software for supplier, for OEM A, for OEM B, and so on and so forth. As mentioned by Geoffroy, this is not always as easy as it intended, but it is way easier than without systems like AUTOSAR. So looking at the next slide, we will see a bit more what I already explained. The decoupling of the software from the hardware is one of our most important things that we are working on. It's also one of the topics that's very important for the software-defined vehicle. And with that, we can also focus on our coding software layers with the intention to increase efficiency and also with the intention to increase quality over time. So how do we do that? So as the AUTOSAR organization, we are publishing 3 main standards, I would say. At the bottom, we have a foundation. In the foundation, we are covering all of our protocols which are used in an EEV system. For example, protocols that are necessary to also connect AUTOSAR Classic with AUTOSAR Adaptive. One example that is very famous when we talk about the service domain is SAM-IP, but there are also other protocols that are very important, like for example event communication, cryptographic stuff that has to fit together between the platforms. And last but not least, the joint methodology towards how to approach building complex systems in an EE architecture of a vehicle. And on top of that, there are 2 variants of platforms, one of them tailored towards microcontrollers, which is called AUTOSAR Classic platform, and one which is tailored towards microprocessors, which is called AUTOSAR Adaptive platform. And for the adaptive platform, additionally, we have initiatives to standardize sensor interfaces, and for the classic platform, we have initiatives to standardize also application interfaces. So if you compare the different platforms which I've just mentioned, the adaptive platform in the middle is really about high computational power, but still serving some degree of safety. We have always a question, why is there an ACV? I would like to pick up the statement, because hardware is a limiting factor. So the software is not basically, or the standard is not the limiting factor. Right, in our today's system, when we use AUTOSAR, we see typically an ACV as a maximum because of the hardware requirement that is sufficient to achieve with a single AUTOSAR adaptive partition. On the other hand, from a safety perspective, AUTOSAR Classic systems are used up to the highest AC level. So if you are combining and decomposing AUTOSAR Classic and adaptive, you can still achieve an SDV functionality according to ISO 26262. And it's basically for real-time features developed and designed for tough real-time environments. And if you look, for example, in the infotainment domain, you usually have low safety requirements. You have, except for some functions, also less restrictive real-time requirements. Good. Having said that, one key aspect of AUTOSAR that is often underestimated is the AUTOSAR methodology. So a lot of people are reducing AUTOSAR to the basic software stack, but I think this is fundamentally wrong. Because with the way how we have modeled the methodology, we have achieved means to speak the same language. So we're using the same language. If I talk to AUTOSAR experts and I talk about a software component, atomic software component, you will immediately know what I mean. Same when it comes to a client-server interface, a sender-receiver interface. And this is usually achieved by the exchange formats we have in the methodology. The methodology is considering a workflow that we live in the automotive industry as of today. So here you have typically an OEM which defines the function, links the functions to each other. You have then as a second step in the middle, physical system architecture which you're building, hardware defined today, as we have heard. And based on that, somebody is doing for this hardware the basic software, so this is the basic software part on the left-hand side. And then we have also application software development in different, for some issues, even in different companies. So the biggest ecosystem I've seen is more than 20 companies integrating into the same AUTOSAR ECU. And if you combine that at the end, you get your software components, your basic software, your ECU extract, and make a complete model ECU out of that. benefits is basically also anticipating the workflow that will happen in the industry and also using the same format. Good. Having said this, I would like to hand over to my colleague, Neumueller. She will give you an introduction. What is AUTOSAR's understanding of a software-defined vehicle?
So, let's see if this microphone works. Yeah, technology works once in a while. Excellent. So, hi. Thanks, Michael, for the introduction. So, already this morning in our keynote speech, you heard about SDV. You will see more presentations about the software-defined vehicle in, well, today and tomorrow. So we wanted to start off by giving an overview of what, from an AUTOSAR perspective, we think are the key technology points and how we see that AUTOSAR supports the SDV architecture. So the fundamental difference between traditional automotive software engineering is, in the past, we had basically at start of production fixed block of software. In the future, with the upcoming SDV, we will see continuous updates, upgrades of the functionality over the air of the software. So of course, the EE architecture, the logical layers must reflect this, they must enable this, so that is works. So that's a very busy picture. I'll try to take you through it step by step. So from a logical view, how do we see the SDV? In this image here, and again, this has a pointer, does not. Okay, well anyway, on the left side here, in this left column, you see the logical layers of the vehicle. So at the very bottom, we have our physical networks, we have our physical ECUs, sensors, actuators. Then layer by layer, we build up the abstractions, starting from the hardware abstraction, the automotive software platform, up to the applications. All of this is mirrored on the right side in the cloud. So we want to develop software throughout the life cycle. We do this in the cloud, we deploy it from there. So all of the left side must be mirrored in the cloud so we can have our continuous development and our deployment from there. All of this is held together by the development, by the workbench, by the DevOps toolchain. So my apologies. So up here we have our tool chains. So this holds all of this together. Very, very obviously, we must decouple the hardware from the software. Otherwise, we cannot continue to develop software throughout the life cycle of the vehicle, and we cannot deploy it to multiple vehicles. This is very obvious. What is also important is that we have well-defined APIs between all of these abstraction layers. Now, unsurprisingly, from the perspective of a consortium, we think that it's very useful to standardize these APIs. And we are, of course, not the only consortium that thinks so. We have multiple here, and so we have guests here. We're very happy to have Sophie here, we have Eclipse SDV here, we have Covesa here. They will be talking in the afternoon. So on the next slide, I will show you which parts are addressed by AUTOSAR, which parts are addressed by other consortia from our perspective. So you will see here mirrored the layers also on the previous slide, so starting with the hardware abstraction API at the very bottom, up to the toolchain API at the top. So it's the same as on the previous picture, the images. And AUTOSAR, the traditional AUTOSAR as you know it, covers here in this red bar basically from the hardware abstraction up to the interfaces between the platform and the applications. So this is the part that is covered by the AUTOSAR standard. New, up and coming, will be presented by Michael later on, are the AUTOSAR open projects, and they will cover also the interface between the cloud and the vehicle. So this is here in this red outline here, the automotive API. This is up and coming. What you see here is we don't cover all of this, and we don't intend to. We have other consortia addressing different parts of the stack. And that makes complete sense. We cannot cover all of this. And we are working very closely together to ensure that what we're building up, that this fits together, that it is compatible, and of course we really, really want to avoid that we have contradicting results. So we have ongoing partnerships for many years, actually with ASAM. We have partnerships with several of these consortia here reflected. So basically, to summarize, what is our goal for the SDV? We are supporting the transformation of the automotive industry for the software-defined vehicle by avoiding parallel development. So we're working together with other consortia to ensure that all of our development fits together and is not overlapping. By enhancing the cross-industry collaboration, we have over 360 partners, I believe. So obviously, yes, the industry is working together in AUTOSAR. And by keeping the organization future-proof. So we have the AUTOSAR Open Project upcoming to keep the organization future-proof, and by retaining the investments. So the standard that we have developed so far, we continue evolving it so that it fits to the upcoming requirements of the industry. Now, I spoke about the logical layers. Let's look at the physical EE architecture in the vehicle. How is the setup for an SDV, and where do we see which parts of AUTOSAR? So at the very center, you have high-performance computers, vehicle computers, whatever name you choose for them. These are the massive, computing, powerful machines that you have in the SDV. They are typically consist of multiple microprocessor cores, of multiple microcontroller cores. This is where the complex algorithms are deployed. This is also where you will see the most frequent updates of the software in the vehicle. And from our perspective, this is where AUTOSAR Adaptive is deployed, together with AUTOSAR Classic, and of course third-party platforms are always an option as well. Now these high-performance computers, they communicate over a high-speed bus, usually an Ethernet backbone, with the zone controllers. Zone controllers, they're based on microcontrollers. So you have here AUTOSAR Classic, possibly multiple instances depending on your use case running on them. And they also serve as gateways between the traditional automotive buses and this high-speed backbone. So you have on the one side the traditional service-oriented communication, new service-oriented communication, and on the other side you're connecting to the traditional signal-oriented world that we have in a traditional automotive engineering. Now, the majority of the ECUs in the vehicle, of course, continue to be simple microcontroller-based hardware. They're the ones operating the sensors, operating the actuators. That is the majority of the ECUs, where we have AUTOSAR Classic running on these machines for, I think, over a decade now, widely deployed in the industry. It is well accepted. So this is how we see the EE architecture typically for SDV. Now, of course, the SDV is also connected to the cloud, otherwise it wouldn't be one. We have a little question mark here, and that's basically because it depends on your OEM where this is connected. So we know from architectures where this is connected to a high-performance computers, we're aware of architectures where this is connected to a zone controller, or it's connected to a dedicated ECU. All of these are valid options, depends very much on your individual design, where you have the entry point from the vehicle to the cloud. So basically, to summarize a bit, one more click. So to summarize, where do we see AUTOSAR Classic? So AUTOSAR Classic is the very, very dark blue boxes here, almost black on this beamer. So AUTOSAR Classic, that's the bread and butter topic. It is deployed on the majority of the ECUs. It is widely accepted in the industry. So we see it in the end ECUs, the zone controllers, and also as partitions in the high-performance computers to ensure the fast startup times, to ensure HLD supervision if that's necessary. So this is what is used everywhere. The new AUTOSAR Adaptive, which is also already deployed in the market, that comes in the high-performance computers because it features the flexible updatability that we require on these machines. It can be multiple instances of AUTOSAR Adaptive on the high-performance computers, and this is all separated by hypervisor technology. And if you choose so, you can have a third-party platform here as well. They can coexist peacefully. It works quite fine. So this is basically how we see AUTOSAR in the SDV. Now, as for the details of what AUTOSAR Adaptive exactly brings to the table, my colleague from the project leader team, Metzker, will give an introduction here.
Okay, thank you, Jennifer, for preparing the ground basically for AUTOSAR Adaptive. And in my part of the presentation, I want to give you an overview of what AUTOSAR Adaptive contributes to the SDV. But I also openly show basically, okay, what's still some way to go for the adaptive platform to completely fulfill current market needs. Okay, now let's have a look at the adaptive platform at the SDV. So, as Jennifer already mentioned, the home of AUTOSAR Adaptive is not on the standard ECUs, sensor actuator ECUs, and the home of Adaptive is also not on the zonal computers. But they completely focus on the high performance computers, and they are also deployed on the microprocessors. So these more powerful compute units with a lot of, with more resources actually, and doing tasks like, for example, advanced driver assistance systems, or being more powerful vehicle computers, and also HPCs take over the role for the IBI typically. Okay, okay. So what's also important is that AUTOSAR Adaptive is not alone on an HPC. So what's quite common is that, okay, you have an AUTOSAR Adaptive partition on an HPC, then you have probably something that's often called a safety island, which is also part of the HPC, but where, for example, AUTOSAR Classic can be deployed. And on other HPCs, like for example IBI HPCs, AUTOSAR Adaptive could share the HPC with other software ecosystems. It could be, for example, an Android for the HMI. So third-party ecosystems are common, and when you think of driver assistance systems, you can also think about ecosystems like NVIDIA Drive OS or other ecosystems. So for AUTOSAR Adaptive, it's also crucial to be integratable with our other ecosystems. So it's not always a stand-alone solution as is AUTOSAR Classic. Okay, so I don't want to stress you with all the details of the small boxes that you see in this picture here. So AUTOSAR Adaptive offers a lot of functionality and is basically structured in so-called functional clusters. It has platform services and it has video services. And when you think about one very important factor of an SDV is its high need for being updated very often to insert new functionality, then you can see that these points here are important. So the update and configuration management is, for example, an interesting functional cluster of the adaptive platform. And the update and configuration management is something that takes care about updates of the local HPC, so just basically one machine. But we also provide what we call a vehicle service, and in this area we have the vehicle update and configuration management, which provides functionality to coordinating the updates of the HPC, but also about other partitions which are required to be updated to introduce new functionality. Okay, for the next slide, I want to extract a little bit from all these different boxes and give you one added value of the adaptive platform, and I think we need to go one slide back. And this is its rich set of protocols that it provides. So if you are an HPC developer, you can use those enablers. For example, in the area of diagnostics, you get the dual-IP support, you get the UDS protocol, you have SOVD. So these are all things that are solved already, and you can basically use it as some kind of library on your HPC. And similar in the area of communication, so we get the automotive-specific service-based communication with some IP. You get a very efficient implementations. This is also a property of an AUTOSAR, that it takes care of very efficient communication. So for example, one property is that AUTOSAR supports zero copy, which makes the communication on the adaptive platform quite fast. Another topic is, for example, network management, so which takes care about, okay, which state is the network, which of the participants needs to wake up or shut down. So this is also some very automotive specific stuff that you won't get anywhere else, let's say open source, and which is provided by AUTOSAR. Okay, let's go to the next slide. Another property is security support. So AUTOSAR, we learned a lot of lessons when in the late stages of AUTOSAR Classic, where we introduced cybersecurity support. And I think with Adaptive we were quite early in supporting security right from the beginning. And there we are continuously adding features. Quite typical and very often uses elements like secure onboard communication, so very automotive specific security control for securing the communication. But we also take care, for example, of topics like firewall or having secure update in the sense that you have authentic updates, so that you can check, for example, the authenticity of updates before the update is done. And finally, another major selling point for the AUTOSAR Adaptive platform is also that the topic of functional safety is basically considered by design from the beginning, from all the lessons learned we have with the AUTOSAR Adaptive platform. And they are just think about topics like end-to-end protection of communication, so that can be used across ecosystems between classic and between adaptive. But you have also an explicit cluster here for platform health management, which contributes also to developing safe systems. So AUTOSAR enables you to be conformant or compliant to requirements which the industry have in terms of cybersecurity, in terms of functional safety. Okay. So with all that, you could think, okay, or sometimes you could have a misconception that AUTOSAR Adaptive is as a complete solution as AUTOSAR Classic. So if you are on a classic or on a, let's say, typical ECU, basically if you have picked AUTOSAR Classic, you're done. You get an OS, you get everything basically that you need to run this ECU. And what you see here is actually that while AUTOSAR Classic provides a lot of functionality and has a lot of those boxes, we have painted here what we call, or the industry often calls it as an HPC full stack. So what's actually a complete solution for an HPC? And this is not fully covered yet by AUTOSAR. And I think that needs to be well understood if you compare AUTOSAR to other solutions. So here again you see basically the functional clusters just reduced to their key points here. And you see that to have a full solution, you need also to have a very, let's say, developer-friendly application development framework, and that not only, let's say, covers things of the basic layer, but also, it's more what you think of when you think of ecosystems like iOS from Apple, where you have a very, very rich application development framework. And this is, of course, not what AUTOSAR currently is aiming for. So this is needs to be added, of course. Also, if you think about that, you might need a container runtime to run containerized software, and of course a full OS. So POSIX, for example, is a POSIX style OS is required, so it could be a Linux or other OSs. And also, AUTOSAR currently does not take care about interprocessor or interpartition communication, also not hypervisors, bootloaders, and more support packages. Some of those elements you still need if you want to use AUTOSAR Adaptive on such an APC together with third-party ecosystems, which might bring their own OS, their own container runtime, and their own basic middleware. Okay. And what we think need to make our minds, or think about very intensively is how we can, or in which areas should AUTOSAR be extended, and should this extension be made in AUTOSAR or in corporations. And therefore, for example, we have seen that part of such an application development framework could be, for example, the automotive API that we currently specifying together with Cuvisa. Work in the area of container runtimes could be done together with what Sophie is doing. So we are thinking, okay, how could AUTOSAR be extended to allow running containerized AUTOSAR applications? And we could also think about, okay, could AUTOSAR provide some standardized interfaces to manage hypervisors, to offer interfaces between the AUTOSAR environment and to hypervisors. So there's still a lot to do and a lot to find out together with partners, and I'm really looking forward to discuss with these other organizations and see their talks that we have today in this conference. And with that, I want to wrap up my part of the presentation. The key point is, okay, AUTOSAR's home, AUTOSAR Adaptive's home is on the HPCs of the SDV. AUTOSAR Adaptive is an important part, but it's not equivalent to the full stack. So as you try to demonstrate, you still need other parts to come to the full solution. However, AUTOSAR Adaptive provides comprehensive automotive-specific functionality in the area of communication protocols and, for example, diagnostics. And it also enables functional safety and cybersecurity compliant development of automotive software. Okay, thank you for your attending this slot, and I just hand over to the next speaker, Michael, as a colleague from the PL team, will take over the classified.
Yeah. Eduard, thank you for giving the overview on the adaptive platform. My name is Mr. Nickl. I'm also in the project leader team of AUTOSAR. And I will guide you now to the AUTOSAR Classic platform and explain you how the AUTOSAR Classic platform is also part of the SDV. You see the picture we have already explained times from my colleagues. We have the HPCs where we see mainly AUTOSAR Adaptive, but also AUTOSAR Classic plays here an important role, especially to enable safety on the HPCs. We have the zone ECUs, which are where we see more or less only AUTOSAR Classic will be used, and we have the ECUs, which you have more or less many of them in the car, in a vehicle. It's the sensor actuators, where you have today the AUTOSAR Classic platform as base, but also in the future we see that it will be AUTOSAR Classic. Okay. Here on all the ECUs, HPCs, zone ECUs and sensor actuators, we see AUTOSAR Classic platform that it will play also a very important role in the future, as it is the base for the current but also for future EE architectures. Okay, what does AUTOSAR Classic platform provide you? AUTOSAR Classic platform is a layered software architecture which supports the hardware abstraction. It provides you the scheduling of runnables and tasks together with an operating system. It provides you communication between applications on the same hardware and over the network. It provides you diagnostics and diagnostic services. It supports functional safety and provides you security mechanisms. As Eduard explained, it's in principle a full stack for a microcontroller-based ECU. You take AUTOSAR Classic and you have everything which you need. Next slide, please. Okay, as I said already, we see for current but also for future AUTOSAR EE architectures that AUTOSAR Classic plays an important role. I would say we have AUTOSAR Adaptive now since 2017. We had our first release, but also AUTOSAR Classic plays an important role, as I said. Why is this the case? We see AUTOSAR Adaptive is not a replacement of AUTOSAR Classic. AUTOSAR Adaptive not a replacement of AUTOSAR Classic. Both platforms will complete each other and will be necessary in a future EE architecture. Especially AUTOSAR Classic is targeted mainly for the deeply embedded ECUs, which have safety critical functionality. We have already seen in the introduction slides, it's up to AZD. It fulfills hard real-time capabilities, and it is designed mainly for microcontroller architectures. The deeply embedded ECUs provide sensor data and actuator access for the higher level functionality. The higher level functionality are realized then on the HPCs or vehicle computers. It is designed for a smaller footprint and a faster startup than AUTOSAR Adaptive platform, and it is based on signal-based communication, but enables or provides you the communication with adaptive platform because it's ensured by bus-compatible protocols like the already mentioned some IP protocol. Okay, next slide please. Okay, AUTOSAR Classic is still evolving, also we call it Classic. It's still a growing platform. We see new features coming up every release. And why is this the case? Because, as I said, it was in the future necessary as a base for the EE architectures, and therefore we need to adapt AUTOSAR Classic also on the requirements we have for SDVs. You see this growing and evolving also with a number of concepts we have introduced in the last release, in release 2311. We had 8 new or extended concepts, where 6 were purely for AUTOSAR Classic and 2 for adaptive and classic platform. And for the upcoming release 2411, we have currently 11 new or extended concepts planned. 4 of them will be only for AUTOSAR Classic, and 7 concepts targeting classic and adaptive platform together to ensure that the same functionality is provided on both platforms and that they are interoperable. Okay, with this, thank you, and I hand over to our chairperson, NiklasHoeret. Again, he will give you an outlook on the future perspectives.
Thank you very much for the overview, and I think you now should have a good understanding where AUTOSAR is right now. And as we have seen, software is evolving rapidly, so also we need to consider where AUTOSAR will be in the future. So let me guide you now to this part, and let's start with the next slide. So here you can see our release schedule. As you see, we are constantly releasing in the 1-year cadence. So the November is usually a very busy month for us in AUTOSAR, because this is where we're publishing our foundation release, our AUTOSAR Classic release, our AUTOSAR Adaptive release, and also the releases for all those interfaces which I've shown before. Coming to the next slide, we have also introduced in the last year the opening strategy of AUTOSAR. So with the challenges of the software-defined vehicle, we understand that we need to open certain aspects of AUTOSAR. First thing that we already did is we extended our representation in the regions. As we have said, AUTOSAR is a global standard. We need to respect and consider the inputs of the regions. We started with regional spokespersons, but we're also looking into extending that further in the future. Then the next topic is third-party collaboration. We are not alone in the ecosystem. We have a lot of colleagues here from Eclipse, from Covesa, from Sophie, from NDS, from ASA. And somebody 100% forgot, so sorry about that. But we need to talk to each other. We need to make sure that the software solutions and the standards we're building for software solutions are compatible with each other. The other thing that we already achieved is Premium Partner Plus program, a potential for premium partners to influence the technical depths of the AUTOSAR direction more in the future. And another thing, in the past we allowed derived application and we had kind of a blacklist. Well, now we have also a whitelist, basically. Applications where we are confident that we can use AUTOSAR outside of the automotive domain. And something which we currently have in the signature process is an easier access to limited scope of AUTOSAR work, which I will show on the next slide. But before we come to that, we have 2 things which we're currently working on, and I will also show some details there. It's the automotive API and also the AUTOSAR Open Framework. So looking at the next slide, we have now the AUTOSAR Associate Partner Lite as something that we want to introduce. As I mentioned, this is currently the signature process. This is a free of charge AUTOSAR membership. It covers all of the protocol aspects you need to interact with an AUTOSAR system, and it's tailored for organizations, for companies that have interfaces to AUTOSAR on a bus level, and it's an easier entry point for those into the ecosystem. Some people ask always how much of the AUTOSAR specification is in this Associate Partner Lite. As we calculated with roughly 2% of that will be available, and the main use case here is interface compatibility. Let's go to the next slide. In the opening strategy, we're also looking at the AUTOSAR Open Framework. The AUTOSAR Open Framework should be framework where we can host open projects. This sounds like now AUTOSAR wants to do competition with Linux Foundation or Eclipse Foundation or other foundations. This is not the case. We only want to put in the AUTOSAR open framework topics that are very close to AUTOSAR. So there's no intention at all to have a competitive environment towards other organizations. And here the goal is that we can collaborate in the principles of open source communities, so with a charter document, with the coding licenses, and that AUTOSAR and non-AUTOSAR partners can collaborate in this open framework together. One of the first examples of the open framework we will see on the next slide. This is basically the automotive API. Here we are considering the use cases that you get a direct access for vehicles users to central data via a gateway. And here you can see that we have different users in the cloud, for example, that will require this data. So what we are currently standardizing is this automotive API, which contains, and we will see this in one of the later slides, certain documents on how we see the AUTOSAR automotive API in the context of the ecosystem, and we also collaborate with AUTOSAR. So let's go to the next one. Here you can see a little bit more in technical details. So what we have, of course, when we have such on the right-hand side, you can see it on the schematic picture. What we have in AUTOSAR is a methodology, the exchange formats, all of the descriptions, which service, which data is communicated in the vehicle. And of course, this is very specific to how the OEM has set up their architecture, on which service certain data is communicated, and so on and so forth. And this needs to be translated to the language the IoT domain understands. And here we are relying on our collaboration with AUTOSAR. So it's a standardized data catalog, which you can see in the upper right corner, is VSS. So we want to link the data from the SAMIP or the ES network with the data that's going to be provided with VSS. As VSS is a data catalog, we still need some payload encoding, some protocol. Here's where we're looking into VISS. As you can see with the API specification and payload encoding, also running in AUTOSAR, and this is where we want to build jointly the automotive API. So next slide, please. So this year, in this year's release, we want to publish the first document recording the automotive API. In the context of openness, we want to publish an explanatory document, how topics like VSS, VISS, and AUTOSAR work together. And then, of course, the requirements we have AUTOSAR internally with respect to the automotive API, as well as a VSS representation in AUTOSAR. And for us, there's a very huge interest in the collaboration strategically between the AUTOSAR colleagues and AUTOSAR. And we have now the prerequisites to have an early open collaboration established. So the AUTOSAR colleagues joining the definition of the automotive API. And the automotive API will also be our first open project in the future. Now, coming to coming to the next slide. Sorry, I was on my wrong schedule, so I'm also still a little bit sleepy. So you can go ahead, Ramon. Here we see market feedback. It's very important. AUTOSAR lives now since 20 years. A lot of people are mumbling that some things are not okay with AUTOSAR, there are things that we need to change. So we have actively listened, or we are currently actively listening to feedback from the market. And who is we? So it's basically Günther and all of the other regional spokespersons giving presentations at conferences where they get questions that indicate some feedback that we get, symbolized by this big red loudspeaker on the right-hand side. And of course, the spokespersons are not alone. Also, steering committee members give presentations in conferences. I sometimes give presentations in conferences. And also our AUTOSAR executive board members have a big network where they are getting feedback with respect what's going well and what's so well with AUTOSAR. So this is a market feedback, so it's not like our opinion, but it's a market feedback which we consolidated and transparently share, so we don't want to hide anything here. And let's go through this feedback by the next slides. So the first feedback on the next click is basically the value proposition of AUTOSAR adaptive platform. So we have seen before from the presentation from Eduard that in reality in HPC a lot of more software components are hosted in the adaptive platforms. So we need to do one thing. This is basically asking what is the value proposition of AUTOSAR adaptive. I think we have explained that with supporting existing automotive and future automotive standards, with safety concepts being Lego bricks to be able to build a certified system, and the security concepts. So we have not been very expressive on that on the last conferences, so there's also more explaining to do. But on the other hand, there's also some things which now, after some years in first projects, we see are necessary to extend. So this is what we mean with looking into the value proposition of the AUTOSAR adaptive platform. The next slide is, the next bullet point shows that we get feedback that the work with AUTOSAR Classic could be improved. So there's still some complexity that can be removed. So we are also looking into some aspects where we try to remove this complexity, and there's also some things that we already initiated, which I will talk at the end of my talk. So before we get there, let's come to the next challenge which we have perceived. So we have perceived that especially on the feedback that we got, especially on the interface that the AUTOSAR standard provides to the applications, it is sometimes broken, backward incompatible, which is of course a nightmare in the sense of software engineering and the use of software. So there was the feedback that we should think about introducing API first principles like lived-in ecosystems and Android around iOS, etc. Then the next feedback we got is that there's a big power struggle. What's the benefit and the drawback of XML as an exchange format? Yeah. And a lot of feedback we get is we should look into other alternatives. Does it fulfill the purposes it was originally designed for? Should we look into alternatives? Should we search as an industry for alternatives, etc.? So this is also feedback. Next feedback that we got is AUTOSAR and open source. So this is a challenge that we have. So we have a history with 20 years, and our ancestors, I call them a little bit provocatively, our ancestors, they had a really good contract for the point in time that AUTOSAR started. But of course now this has to be challenged. So how can we, as an automotive community, deal with AUTOSAR and open source? So this is a question and feedback that has brought to us that we as an AUTOSAR organization need to provide an answer what will be possible around that in the future. And the last challenge that we have perceived is globalization. So we need to be able to involve more the standards and feedbacks from the regions. So this is also something which we of course started, but where we still get the feedback, it's not enough, we need to do more, we need to get more the feedback from the regions on board. So these are the challenges. Now let's have a look what we already did with respect to those challenges. So the next slide. One thing, AUTOSAR Adaptive has had a lot of changes in its first years due to the growing demand. So we are looking now into stabilizing AUTOSAR Adaptive. So our clear goal for 24/11 is a stable AUTOSAR Adaptive release, which is a reliable base for OEMs for the future. So what we are planning here, we are planning to implement breaking changes that we are aware about that are necessary to have a good architecture for the future. So we are prioritizing all efforts to achieve the stable AUTOSAR Adaptive release. We are striving, and this is a little bit anticipating the thought of the API first principle, to also strongly look on the backward compatibility of APIs. And if you guys in the audience have some changes that are necessary to say, okay, this is something that we need to do in such a stabilization release, engage yourself in change requests towards the AUTOSAR consortium, engage yourself in concepts if necessary, and because this is now the point in time where we can consider this accordingly. So the next slide shows a little bit how we want to deal with the complexity of the AUTOSAR of the AUTOSAR Classic platform. So Ray, if you do me the favor and go to the first animation. So first of all, we're thinking about there's a concept of reclustering. So we have built the AUTOSAR Classic platform with a lot of small modules, and the adaptive platform with a big stack, which are the functionalities. Now we're thinking about reclustering those in the sense of that we want to combine several modules of a stack into a cluster. In AUTOSAR terms, this is changing direction from ICC 3 level to ICC 2 level. So next animation please. So with that we also would like to get rid of some configurational overhead we have to configuring how module A is interacting with module B and leave more freedom to the implementers. So the next thing that we're looking into is feature cleanup. So 20 years of AUTOSAR, some features have been introduced. A lot of features have been introduced. Some of them are used always, some of them are used sometimes, and some of them are frankly used not so often. So we also need to think about getting rid of some previous features with that simplifying the standard. So next animation, that would mean that certain boxes might disappear in the future. Good, then next step is with feature cleanup and with this directional towards ICC 2, we think that we can get way better in what we describe in the system template. We can get rid of some topics which we're doing in the ECU configuration, and with that overall we plan to make the application of AUTOSAR Classic, as it is a fundamental base in the software-defined vehicle, also easier for the companies in the future, supported by coding measures in the standard. Good, next one. So these are the topics we have perceived as challenges for me personally as chairperson and representing the steering committee. It's very important if you see such a red question mark popping in your head, where you say, okay, this is a challenge we still have at AUTOSAR. It's not one of the challenges that is on the slide. Come to us, because we as a community need to solve the challenges that are brought in software-defined vehicle to AUTOSAR and other standards in the future. So to conclude my talk, AUTOSAR technologies are the base for SDV. AUTOSAR Classic is still evolving. It's not like something that is existing in the box for 10 years. There is still some invest in there. The market feedback is very important, so we need your feedback to identify the open challenges. And of course, we are a community, so we need to solve these open challenges as a community. So engage yourself, participate, and my last words is very, I would say very deep, or not so deep, it's basically united we stand, divided we fall. So I think this applies to our community in AUTOSAR, but this also applies to our collaboration with other organizations in the SDV ecosystem. So thank you very much. Hopefully I was able to give you an outlook, also perspective in the future. Looking forward to your feedback. Reach out to me or my colleagues from the steering committee, and thanks a lot.